Welcome to the channel Professor Davinci. Probability for statistics. Probability is all about counting randomness. So counting randomness in the meaning how much time it occurs, the likeliness. Suppose for example I am flipping a coin. So how many times I can expect the head or how many times I can expect the tail. Or suppose I am just randomly picking some color of item from a bag. So how much possible I can pick the red color item or blue color item. So that is called the randomness. It is the basics of how we make a prediction in statistics. We can use probability to predict how likely or unlikely particular events may happen. So I can say today may rain or not. So this is the just a problem statement for the probability of raining or not. We can also, if needed, consider the informal prediction beyond the scope of the data which we have analyzed. Probability is a very essential tool in statistics. There are two problems on the nature of their solution that will illustrate a different. For example, whenever it comes with the probability, two problems we have. For example, problem number one: assume a coin is fair. What is coin is fair? So every time I can toss, it may have a head or tail in a equal distribution. If a coin tossed for 10 times, how many times will we get tail on the top? I have a coin, so coin have two faces. One is head, second one is tail. If I toss the coin for 10 times, then how many times I can get the tail? This is a problem one. So this problem one we can solve mathematically. Mathematically we can solve. Okay. So that example I will be explaining now. Okay. Then the same thing, the second problem. You pick a coin. Suppose for example I need to pick a coin from the pool of the coin, or is only one coin is there in the bag. I am just going to pick the coin from the bag. Question here is that does each face have equal chance of appearing? Meaning, first time I am picking from the bag, I get head. Second time I pick, I get tail. Third time I pick, I get head. Fourth time I get tail. Is it do I get the same thing? That is equal number of heads and equal number of tail I can able to pick the coin? No, because it is depend on the probability. Suppose for example first time I pick, I may get the head face, and second time again I can have the head face, and third time may also I can get the head face, and even for 10 times I pick the coin, 10 times I may get the head, completely head faces, or sometimes I can get completely 10 faces of a tail. 10 times I pick, 10 times I get the tail face, or sometimes I can get a 3 times a head face or 7 times tail. So like this it's randomly distributed. I cannot say that which one will come. So in this case, this kind of problem, that is this say problems 2. Problem 2 is a statement problem, statistics problem that can use a mathematical probability model determined in problem 1 as a tool to seek the solution. So for this problem, I cannot find the solution directly from the mathematical probability problem. I have to use this mathematical problem as a solution, as a tool to find the answer for this problem. Okay. So in short I can say the answer to neither question is deterministic. Okay, so either problem 1 or problem 2 are deterministic. Tossing a coin produces random outputs which suggests that the answer is probabilistic. So I can get a tail or I can get a head. The solution to the problem 1 starts with the assumption that the coin is fair. It later proceeds to logically deduce the numerical probabilistic for each possible counts of tail. After a toss resulting from 10 tosses, the probability of getting the counts I may get a 0 counts, or I may get 1 times, or I may get even 10 times the same tail. So the probability counts lies between the range from 0 to 10, any number it can come. The solution problem, now the solution problem, the solution for the problem 2, the solution for the problem 2 start with an unfair tosses. We do not know if it is fair or biased. So if I toss a coin, or if I want to pick a coin from the bag, it is unfair because I don't know how many times it may get, or it may fair or unfair or biased. The search for an answer is experimental. Toss the coin, see what happens, and examine the resulting data to see whether they look as if they came from a fair tosses or a biased toss. Okay, so usually in problems 2 we will not get the fair toss, always we get a biased one. So one possible approach to make this judgment would be the following. Say toss the coin 10 times and record the number of count when you got a tail. Repeat this process tossing 100. So first we need to toss the coin for 10 times. You just need to keep the recording how many times I get the tail, and then do it for 100 times. Okay, then finally compile the number of times you got tail in each of these 100 times. Okay, compare this result and produce the frequency table. So for this, what you need to do, we need to make the frequency table. Already we have spoke about frequency table. So if we make the frequency table, then these frequencies produced by the mathematical model for a fair toss in problem 1. If the frequencies from the experiment are quite dissimilar from those predicted by the mathematical model for a fair toss, and the observed frequency are not likely to be due to chance of variability, then we can conclude that toss is not fair. Okay, so first mathematically you can derive this equation. Suppose for one coin is 1/2, probability of getting a tail is 1/2. So if I toss for 10 times the same coin, what is the probability of getting a toss? So do it mathematically, you will get some answer. So same mathematically, you just do it in real time. So do it real time, toss the coin for 100 times or 10 times and check the result, how many times I get the tail, and compare with this result with this one mathematically. If this one produces the same output, then we can say it is a fair toss. Or if we get the different in real time and different in a mathematical, then we can say that it is a biased one, or it is not fair. Okay, so in problem 1 we form our answer from logical deductions, but in problem 2 we form our answer by observing experimental result. Okay, this is the two difference we have in the problem of a probabilistic. Okay, right? So now let me do a small exercise to understand this problem of 1. So for example, say I can say this is a question number 1. Statement: 2 fair coins, say 2 fair coins are tossed. Okay, in same time, simultaneously. Then I need to get how many times I get only one head. So what is the probability? What is the probability of getting one head? So what is the probability? For example, 2 coin I'm tossed. So if I toss a 2 coin, what is the outcome I get? I can get 2 coin may have a head and head, 2 coin may have head and tail, or 1 coin is head, 1 coin is tail, or 1 coin is a head, tail, and another coin is head. So these are the 4 possible outcome if I toss here 2 coins, right? So what is the probability of getting at least one head? At least one head. This is the 1 and this is the 1. So total, so we can say the probability, the answer is the probability, you can say the probability of one head equals, we can say that number of outcome is 4. We will get 2 head out of 4 outcome, so which is equal to 1 by 2. And similarly if we have suppose for example, if I want to toss 3 coins, if I want to toss 3 coins and I need to get at least 2 heads, okay, so 3 coins, if I toss 3 coins, what is the possible outcome? So a head, 3 coins may have a will have head, then head, tail. Then I can have first coin is head, second coin is tail, third coin is head, then first coin head, second coin and third coin, then first coin, second coin and third coin, then first coin, second coin and third coin is a tail, then first coin, second coin, third coin, and finally all 3 are tail. So this is the total 1, 2, 3, 4, 5, 6, 7, 8. So total I have 8 outcomes. So what is the probability? The probability of 2 heads, getting a 2 head, so which is equals, where is the 2 head? I can change the color. 2 heads, 2 heads, 2 heads, and this one 2 heads. So total 4 by 8, which equals 1 by 2. Okay, so this is how we mathematically find the answer for probability of an occurrence of the events. Clear? See you, bye bye, have a great day.